All right, part 4.7, part 2, zeros of linear functions. Today you're going to learn how to find the zeros of a linear function. Well, really it's just one zero for linear function and what that means. And that'll be important too for when we get into solving quadratics with factoring, because you'll have to learn how to find the zeros of a quadratic function. And we can solve it algebraically and graphically. So the first thing at the top of your page says, the key concept is that zeros of linear functions are values of x such that f of x equals 0. So f of x equals 0. So they're values of x for when f of x equals 0. So to find the zeros of a function, you make f of x equals 0 and then you solve for x. So for the first two examples, you would take f of x, make it 0, equals x plus 3, and then solve for x. So we'll subtract the 3 over and get negative 3 equals x. And that's your answer. So now it's easy, but we also have to think about what does this mean? Because we have to be able to transfer the skill to more complicated situations. So if you wrote this as a coordinate, what would it look like? If you wrote this answer as a coordinate. Ethan? Yes, the x is negative 3, and we made f of x equal to 0. So if you think about that, and if you graph this equation, negative 3 comma 0 would be the point where it crosses which axis? The x-axis. So this is also representing your x-intercept. So when you find the 0 of a function, you're finding the x-intercept. That's what's going on here. Let's do that for the next one. So 0 equals negative 2x minus 8. Add the 8 over. You get 8 equals negative 2x. Divide by negative 2, and you get x equals negative 4.
Let's go.
Okay? And graphing, when you're looking at the graph, the solution, or the 0, is where it crosses the x-axis, or your x-intercept. So for the first graph, it would be right here at x equals 2. You stop touching the protractors, please. And what would the 0 be on the next one? Reese?
Negative 1.
Yeah, negative 1. Okay, don't flip your page over yet. We're going to take a few notes at the bottom. So we are going to write down all of the terms that mean the same thing as 0. Zeros, rather. So when you're finding the zeros, other terms that you might see that mean the same thing are solutions. So when it says to find the solutions to the equation, you're actually going to find the zeros. So you set it equal to 0 and solve for x. So solutions, I mean the x solutions. And other terms, the other term, it would be x-intercept. Means the same thing as finding the 0. And the last one is roots. Roots is another term used interchangeably with these three terms. It just means finding the 0 or finding the x-intercept. Okay, there's another note that we're going to write beside it, and it's to solve a linear equation. To solve a linear equation, means to find the 0 / x-intercept. Okay, so that's a key concept there. Solving a linear equation, or any equation really, means finding the x-intercept, finding the zeros. All right, you can go to the next page. Here are some basic examples. It says find the zero of each linear function. Really, it's just one zero. Linear equations will only have one solution at the most. When you get to quadratics in chapter 8, then we'll start looking at when you have two solutions. And then if no zero exists, sorry for the typo, you would just write none. So let's think about that for a second. What kind of line would not have any zeros? Which means it wouldn't cross the x-axis. It wouldn't have an x-intercept. Think about poster. Amelia? Well, an undefined line, a vertical line, does cross through the x-axis. Brody? Well, if it's in point slope form, then it would look like that. Well, it would be right there. Yes. So not vertical, not if it's in slope intercept form. Jackson? Horizontal line, yes. So horizontal lines, might want to write that down. Horizontal lines will not have solutions because they don't have an x-intercept. They have a y-intercept, but they don't have an x-intercept. And we'll see some examples of that here. So for one, we're going to replace f of x with 0 and solve for x. So subtract the 8 over, divide by 10, and get negative 8 over 10, which is negative 4/5. Number 2, if I make f of x equal to 0, that would be 0 equals negative 3. Wait a minute, that's not true. Even if you add 3 over, you get positive 3 equals 0. So that's not true, which means that there would not be any zeros, so you would write none. And this means f of x equals negative 3 means y equals negative 3, and you know y equals negative 3 is the equation of a horizontal line. You should know that. And then the next one, so 0 equals 12x. If I divide by 12, you get x equals what? Reese?
0.
Yes, 0. 0 divided by 12 is 0. And at first it might appear that that would be no solution because you get 0, but that's the difference. No solution means you get something equals something that's not true. But if you get x equals 0, then that is a solution. That just means it crosses through the x-axis at the origin. So you'll have a question like that on your homework. And then number 4, same thing. Let's have an x minus 10. Add the 10 over, divide by 7. You can just write it as a fraction, 10/7. And I'll give you a head start on 5 and 6. Are you finished?
I almost. I'm finished. Let's wait for number 8. Is that true?
Okay, number 5.
I never
What'd you put for 5? Sammy? Yeah, none. No solutions. What'd you get for number 6? Logan? Yes. Any questions about those? All right. Now the next part is graphing, obviously. So we're going to find the solution by graphing, which means where the x-intercept will be. So 3x minus 3, has a y-intercept at -3. So we put a point at -3, and then the slope is +3. So go up 3/1. You should only have one protractor on your desk. And up 3/1. Okay, draw a line through it. And you get x equals, crosses through the x-axis at 1. For number 2, this would be f of x equals -4, means y equals -4, which is the equation of a horizontal line. So you would plot -4 on the y-axis and draw it going horizontal. Since it will never cross through the x-axis, you would write none. No, don't write 0, write none. What did you say? No. Well, lines can't bend. Yeah. It's not x equals 4. Sorry, it's y. I just drew the y accidentally looking like an x. Okay. Next question. We'll do 3 together and you can do 4 on your own. So for 3, this has a y-intercept of 4 and a slope of -1. So you go down 1/1, down 1/1. So slope is -1. So that would be x equals what? Raise your hand, please. Ethan. Yes. Because it crosses through the x-axis at 4. Now try number 4. Try 4. I'll come and check your answer. Good. Yep. If you feel comfortable, you can move on to the word problem after you get your answer.
Who is Kevin? On TikTok. Oh my god. He sings stuff on TikTok.
I want you to solve it by don't solve it. This has a Your y-intercept is -2.
Oh.
Not your x-intercept. Good. Yes. Okay. For those who I didn't get to check or those who got it wrong, shh. So remember, you guys, steps for graphing, you plot B. B is your y-intercept. Don't get confused with y-intercepts and x-intercepts. So you plot -2, you go up 1/2, up 1/2, and then draw your line. So the y-intercept, the solution, your x-intercept would be 4. Okay, so let's do the 2 word problems. It says a bus is driving at 60 miles per hour toward a bus station that is 250 miles away. The function d equals 250 minus 60t represents the distance from the bus station. The bus is t hours after it has started driving. So that means that it starts, at 250 miles away, and d is how much distance it has left to travel. So as it gets closer to the bus station, that distance is decreasing and it's getting closer to 0. So find the zeros of 0 and describe its meaning. So by finding the 0, that means we set y equal to 0. In this case, it's d. So set your equation equal to 0 and solve. So you would add 60t over. Well, if you move the 250 over, you would have to subtract it because it's positive. So I would just add the one that's minus. Shh. And then divide by 60. So what's 250 divided by 60? Raise your hand, please, like decimal. Decimal. Eli? Let's just do 4.2 then. So 4.2 hours. And then what would this mean? It takes 4.2 hours to do what? Reach the bus station, yes. So it takes 4.2 hours for the bus to reach the station. Are you drawing on the desk?
No.
All right, number 2. You and your cousin decide to walk the 7-mile trail at the state park to the ranger station. The function d equals 7 minus 3.2t represents your distance d from the ranger station after t hours. And it's minus because the distance you have left to travel is getting closer to 0. Find the 0 and describe its meaning in the context of this situation. Identify the domain and range. Okay, so let's do the same thing. Set d equal to 0. Add the negative term over. 3.2t equals 7. And find 7 divided by 3.2. Sammy? So let's do 2.2. 2.2 hours, which would mean it takes 2.2 hours for you to walk the 7-mile or hike the 7-mile trail. Then it says to identify the domain and range. So we'll get some practice on domain and range. So domain here would be t. So let's set it up in interval notation. So what's the smallest number? When does time start and when does time end? That's what you're asking, Elena.
0.
0 to
2.2.
yes, because that's the time it takes for us to get back to the start. Or I don't know if it's a loop trail, but get to the ranger station. And how about the range? That'd be d, the distance. So it's the shortest distance you have left to travel to the greatest distance you have left to travel. Brody?
0, 3.2.
Where are you getting 3.2 from? Oh, that's the rate. That's your rate of walking. But how many miles total is the trip? How many miles is the trip?
7.
No, d is distance. And then we are going to graph it because it says to graph. So this would all be in According to our domain and range, we're working in the first quadrant. You just draw a sketch, okay? You don't have to graph it on graph paper or anything. So our domain is 0 to 2.2. So all we need are 2 tick marks down here. And then we could draw a point a little bit after 2. And this would be hours. And then your range is from 0 to 7. So 1, 2, 3, 4, 5, 6, 7. Put a point up here. This would be distance in miles. And then you draw a point from one intercept to the other. Or sorry, a line from one intercept to the other. Alrighty. So that's the end of this lesson.